In the last lesson, you learnt the basic principle of calorimetry, that we can measure the increase in the temperature of water or something like that and use that to calculate how much energy was released in a reaction. So we're now going to apply that, and the example we will use is heat of solution. That's when we dissolve a substance, heat is absorbed or released when that substance dissolved. And we're going to try to calculate for a particular substance how much heat is released or absorbed for each mole that we dissolve. That's the molar heat of solution. So how will we do this? You can probably work out what we will do from last lesson. We're going to take a known mass of the substance. We need to know the mass very carefully so we know how many moles. We will take water, a very carefully measured mass or volume. We'll measure the temperature. Then we do the reaction. We'll dissolve the substance in the water and we'll measure how much the temperature increased or decreased. Now, from that change in temperature, we can work out the total heat that went into the water. And from the mass of the substance, we can work out how many moles we've got. Now, I've put that on a slide, so you can read through that if you want to, just to help you understand it. But what do the calculations actually look like then? To process our data, the first thing we will do is find the amount of heat that was absorbed or released. And that's to do with the temperature change in the substance we heated. We'll use Q equals mc delta T, the same as last lesson. But we will use the total mass of the water plus the chemicals. If I take 100 mils of water, or 100 grams, and I add 10 grams of a substance I'm dissolving, my total mass is now 110 grams, and all of that needs to heat up. So I'm going to use the total mass of the water plus the chemicals, and the chemicals in there may change the specific heat, but we just assume that it's the same as pure water. Okay, it doesn't change by much. And we normally convert that to kilojoules at the end because that's the conventional units we use. So that's how we find the heat absorbed or released in the reaction. Now we want to find the number of moles. So we know the mass of the substance that reacted, and so you can easily use number of moles is mass over molar mass to find the number of moles. If we were using solutions or something instead, you could use the appropriate formula. So we can find the heat, we can find the number of moles, and so how do we find the heat absorbed or released per mole? Well, when you see per, that's normally divided by. So this is going to be the heat divided by the number of moles. So if you divide your answer from number 1, the total heat released, by your answer from number 2, the number of moles you had, you will get the amount of heat released per mole of substance that dissolved. That's your molar heat of solution. Now, why does this get tricky? It gets very confusing when you actually do this in practice. The reason it gets difficult, and I'll put this on the next slide, we'll just click through, is because if you look at the left-hand side, you've got mass in that equation, Q equals mc delta T, to find the heat that was released or absorbed. If you look at the right-hand side, when you're finding the number of moles, you've got mass in that formula as well. And so the most common mistake students make here, apart from getting units confused, the most common mistake is getting confused about which mass to put where. You've got to be very clear that on the left, that's the mass of the substance we are heating when we capture the heat from the reaction. On the right-hand side, that's the mass of the actual substance that reacted. And you can see why it gets confusing because in this experiment, we are adding the solid solution into the water. So yes, the one on the right, the number of moles, that's just the mass of the solid substance, and I find the number of moles. But the one on the left, that mass is going to be my mass of my water I heated, but I have to add the mass of the chemical. So try to focus on what mass am I putting in each of these. And I encourage students to keep these two calculations very separate. Don't jumble everything up. If you are doing calorimetry, in your head think, I have to do two very different calculations. First of all, that one on the left to find the heat energy. Second, the one that's on the right to find the number of moles of the substances in the reactions. And once you've got both of those things solved, both of those values, then you can bring them together at the end by dividing one by the other. Okay, we'll do the practice example and we'll do the calculations and some practice questions, and then we'll do a different type of investigation next lesson to give us more practice at using this.